In this video, I'd like to talk about the eye and how it works. We are mainly visual beings and rely on sight as our main sense. And the eye is very similar to a camera. It's a good analogy to have. And there are two lenses in the camera of the eye. There is the cornea, which is the clear window at the very front of the eye, where people put their contact lenses if they're contact lens wearers, which is 2/3 of the focusing power, or the course correction. And then there's a lens inside the eye called the crystalline lens, which is the remaining 1/3 of the focus, or fine-tuning. And the reason we've evolved to have this two-lens system is that we need to be able to change our focus from the distance, looking at the horizon, to near visual tasks such as reading. And it's the lens inside the eye, the crystalline lens, that can change its shape and so alter the focus. There is one organ in the body, however, that continues enlarging throughout life, and that's the crystalline lens inside the eye. And this has two consequences. The first is that when we get to our mid-40s and onwards, it has a reduced ability to change its shape to focus for near, and therefore reading becomes more difficult, and we have to wear reading glasses. The second consequence in some people is that it can go cloudy as it continues to enlarge, which is a cataract, and that sometimes requires surgical intervention if it's interfering with the vision. We also live in an environment where there's a huge range in light intensities, from dawn and dusk situations to bright sunshine, and therefore there needs to be a mechanism to regulate the amount of light falling on the retina, the photographic film at the back of the eye. And that's the function of the pupil, which is a hole in the centre of the iris, the coloured tissue at the front of the eye, and the pupil can enlarge, get bigger, or constrict, get smaller, by various muscles that are working around the pupil to regulate the amount of light falling on the retina. So it gets bigger in reduced lighting, dawn and dusk situations, and the pupil gets smaller if there's bright sunshine, to get just the right amount of focused light falling on the retina. Now, the retina is the photographic film at the back of the eye, and it's about the most sophisticated bit of tissue in the whole body. There's nothing that works harder than the retina. And the function of the retina is primarily to convert light into electricity. We do not see with our eyes, we see with our brain due to electrical circuits moving within the brain, and therefore we need to convert this light into electricity to enable us to see. And there are certain cells called photoreceptors, and there are two types, rods and cones, that are working flat out all the time in order to convert light into electricity. The retina has two main areas: the central part of the retina called the macula, which is where the cones are primarily situated, and that's concerned with detailed fine vision and colour vision, and then the peripheral retina, concerned with side vision, is where the rods are mainly situated. And all this information, all this electrical information, is gathered in the optic nerve, which is the nerve that transmits the messages from the eye to the brain. About 1/3 of all the information going to our brain comes from our eyes, so it shows us that we're very much visual beings. And in actual fact, the way we've developed is slightly unusual, again because we have our eyes at the front of our head, but the particular part of the brain that's concerned with vision is called the occipital cortex, which is at the back of the head. So there are extensive connections between the front and the back of the head, from the eye to the occipital cortex, to transmit the messages to the brain. So you can imagine that there are lots of problems both with the eye and with the brain that can result in reduced vision and difficulty with sight.